Hello, everybody. Welcome to lesson number 2 in our math class. Sorry, I'm still not there, but hopefully I will be soon. I'm working on some ways that I can get some feedback from y'all and we can kind of communicate a little bit better. But I did talk with some of your teachers and I got some feedback about the first lesson, so hopefully we can address some of those questions you had. And moving forward, you can communicate your questions that you have to me. But hopefully, also, I will be there very soon. The topics slash questions we are going to look at today is firstly the divisibility rule for 8. And I'm going to have you think about why it works, because I want you to think about why these rules work. And then we'll talk about how do we know when to stop finding factors. I heard that that was a question in class, so we're going to address that. It's a really good question. And then thirdly, we will talk about common factors and the highest common factor. We'll do some questions and problems around that. So, the divisibility of 8. Here is the rule. Are the last 3 numbers divisible by 8? If yes, then the whole number is divisible by 8. I want you to think about why this works. This is obviously applicable when you have really big numbers like thousands and millions. But I want you to think about why. Why would this work? So I want you to pause the video. I want you to talk to someone next to you, let's say for a minute. Write down your answer. If that's not possible, you can just think about it yourself and write down your answer. But yeah, take a minute, see if you can figure this out. Okay, so before I fully explain it, I want you to think about another thing. Is 1,000 divisible by 8? Maybe you're really good at math and you figured it out, or you already knew, but yes, 1,000 is divisible by 8. And this is actually essential in understanding why this rule works, right? So 8 can go into 1,000 and not have any remainder. So that means any multiple of 1,000 is also divisible by 8. So let's say 1,000 times 2 is 2,000. That is divisible by 8, right? Because 8 can divide both of those thousands that are in there. So any multiple like this down here is divisible by 8 because 1,000 goes into this 132 times, which means you could divide it by 8 as well because you could just multiply whatever you got from this to get that, right? So anything that is bigger than 1,000 that ends in 000 is divisible by 8. And let's think now, like if we had 1,008, that would also be divisible by 8, right? Because the 8 can be divided by 8 one time. And then the rest of it, 1,000 can be divided by 8. Or like 1,016, right? 16 can be divided by 8 two times. And the 1,000 is also divisible. So if we look at these numbers, right? Are they divisible by 8? Take a second. Let's see if you can figure it out. So this first number, 120,064. So our rule says look at the last 3 numbers, the last 3 digits, and see if they're divisible by 8. So the last 3 digits are 0, 6, 4. So 64, is that divisible by 8? Yes, it is. So this whole thing would be divisible by 8 because 120,000 is divisible by 100, or 1,000, sorry, and then the 64 is divisible by 8. So 8 can divide this whole thing. What about this? 1,118. So we're going to ignore this. Is 118 divisible by 8? No, it is not. So this whole number is not divisible by 8. So as you think about these divisibility rules, right, they're all kind of connected. They all have reasons why they work. Continue to think about why they work together and why we're using the ones that we are. So moving on to this question, which I heard was asked in class, which is a really good question. How do we know when to stop finding factors, right? How many legs should our factor bug have? Should it just go on forever? The answer to that is no, right? Each number has a set amount of factors, but how do we know when to stop? I would like you to again pause the video and talk to a buddy or just think by yourself and come up with an answer. How do we know when to stop? Why do we stop? When do we stop? So take a moment, pause the video, write your answer. So I'm going to give you a few things to think about, and then I will show you an example that kind of explains how we know when to stop. So things to remember. Factors can only be whole numbers, right? 1, 2, 3, 4. We can't have halves or decimals. Factors cannot be bigger than the original number. So if we're looking at the factors of 10, right, 11 is not a factor of 10 because when you divide it, you don't get a whole number, right? And then each factor pair eliminates other potential factors. So here is kind of the key to figuring this out. So let's think about this question with keeping this in mind, right? What are the factors of 12? The very first factors that we always know when we look at any number, right, is the factors of the thing itself, 12, and 1, right? So now we know that anything smaller than 1 is not a factor, and anything bigger than 12 is not a factor, right? So we've eliminated a bunch of numbers. All the numbers above 12, all the numbers below 1, right? We can continue this process. The next factor is 2 and 6, right? 2 times 6 gives you 12. And this has actually eliminated a bunch of other potential factors, right? There's no whole numbers between these, but there is a bunch of whole numbers between these, right? 7, 8, 9, 10, 11. All of those numbers are not going to be factors, right? Because there's nothing smaller to multiply by, no smaller whole number to get something in between these two. So this 2 and 6 has eliminated the numbers between 6 and 12. So 7, 8, 9, 10, 11. Those are all not potential factors anymore. We can continue, right? The next factor is 3 and 4. 3 times 4 is 12. So that eliminates, again, anything between these two numbers. So 5 is not a factor. And anything between these two, these are one number apart, so that doesn't really matter in this case. But there's also no whole numbers between 3 and 4. So now we know there are no other factors, right? There's no potential whole numbers between these two things, and this times this gives us 12. Another situation you might see is you get to the middle of your line and you have some number multiplied by itself, like factors of 25. That middle part of your line will be 5 because 5 times 5 is 25. That also tells you you're done. You found all the factors. But keep in mind this big number line. That's kind of why I introduced it to you last lesson. And if you're doing factor bugs, right, your legs will start to get closer and closer together. Eventually, you will come to a place like this, right, where you have 3 and then 4, and there's no whole numbers in between. Or the numbers in between you've tested and they don't work. That's also a way to know. But each factor pair eliminates other potential factors, right? Another way to think about this or visualize this, right? Factor pairs of 12. You can imagine that we're getting these subdivisions of 12, right? And you can arrange them in geometric patterns like one row of 12 columns, right? Or 2 rows of 6 or 3 rows of 4, right? You will eventually run out of arrangements for these. In this case, it's at 3 and 4. So as you go through your practice of finding these factors, remember that each time you find a new factor pair, you've eliminated all of the numbers in between the last factor pair, right? So now I'm going to give you some statements. I would like you to decide if they're true or false. And if they're false, I'm going to have you talk to someone next to you and think about why they're false. Okay? So the first one, every number is a factor of itself. True or false? Take a moment. Think about that. Is that true or false? This is true, right? If we go back a slide real quick, 12 is a factor of itself. 12 times 1. Everything times 1 is itself, so every number is a factor of itself, right? 1 is also a factor of all whole numbers, right? Here's your next statement. If 2 and 4 are factors of a number, then 8 is also a factor of that number. Take a moment, think about if it's true or false. So this statement is false. Think about why this is false. Think about situations this might be false in, right? So take a second, talk to someone next to you, or write down your answer on why you think this is false. So, if 2 and 4 are factors of a number, then 8 is also a factor of that number. So, just by thinking about some examples, we can prove this false, right? Even just thinking of the factors of 4, right, which would be 1 times 4 and 2 times 2. 8 is not included in that, right? But 2 and 4 are both factors of that number. So that makes this statement false, right? Or if we think about multiplying, like 12 is another number that 2 and 4 are both factors of, but 8 is not, right? 8 does not go into 12 an even amount of times. So these statements can be tricky because we know a different rule that's true, right? If 2 and 3 are factors of something, then 6 is a factor, but that's not true for 8. Here's your next statement. Every whole number has at least 4 different factors. Is that true or false? Take a moment to think about it. This is false. So every whole number has not 4, but 2, which would be 1 and itself. Because certain numbers, special numbers called prime numbers, only have 2 factors. Like 7, right? 7, its only factors are 1 and 7. 2 does not go into 7 an even amount of times. 3 does not. 4 does not. 5 does not. 6 does not, right? It's just 1 and 7. And it is a special number called a prime number. So prime numbers only have 2 different factors. So that makes this statement false.